Logic gates. Logic gates are digital circuits which are capable of performing particular digital functions by operating on a number of binary inputs. Logic gates are the basic building blocks of any digital circuit. Logic gates are basic logic gates, universal logic gates, and some other logic gates. Basic logic gates are AND gate, NOT gate, and OR gate. Universal logic gates are NAND gate and NOR gate. Other logic gates are XOR and XNOR gates. Fundamental gates. Basic logic gates are the fundamental logic gates using which universal logic gates and other logic gates can be constructed. AND gate. The AND gate output is high if all of its inputs are high. The output is low if any one of its input is low. This is a symbolic representation of an AND gate. A and B are the inputs. Y is equal to A and B is the output. Now we can draw the truth table and timing diagram of AND gate. This is A, B, which are the inputs. Y is equal to A and B is the output. A, B, Y is equal to A and B. When both the inputs are low, that means 0, 0, the output is 0. In the timing diagram T1, 0 for A and 0 for B, therefore Y is equal to 0 also. Now for A is equal to 0 and B is equal to 1, that means A is low, B is high, the output is low or 0. That means in T2, A is equal to 0 and B is equal to 1 and Y is 0. Now for A is equal to 1 and B is equal to 0, again Y is equal to 0. That is for T3, A is 1, B is 0 and Y is equal to 0. When both the inputs are high, the output is high. That is for T4, A is 1, B is 1 and Y is equal to 1 also. That means the output is high when both the inputs are high, and the output is low when either of the input is low or both. Now we can construct an AND gate using two diodes. This is a circuit diagram of a AND gate using two diodes. When both inputs A and B of the diode are connected to ground, so it will be look like this. The both diodes are connected to ground, and here is a 5 volt supply, and this is the resistor, and we have the output Y is here. Now since both the diodes are grounded, both the diodes are forward biased, hence current conducts through the resistor to the ground, and therefore no output present across Y. Therefore when both A and B is grounded or low, the output is low. Now when one of the input is connected to ground and other is connected to the positive terminal of the battery, that means like this. This diode is connected to a positive terminal of the battery and the other one is connected to ground. Therefore this diode, the one which is connected to ground, is forward biased, so the current passes through this diode and goes to the ground. Therefore there is no output. That means when either of the diode is connected to the positive terminal of the battery, the output is 0. Now when both the diodes are connected to the positive terminal of the battery like this, therefore the diode does not conduct, we have the output across Y. So in this way this circuit acts as a AND gate. Now the OR gate. For OR gate, the output is high if any one of its input is high, and the output is low if all of its inputs are low. This is symbolic representation. A and B are the inputs. Y is equal to A or B is the output of the OR gate. So this is the truth table and this is timing diagram. When both A and B are 0, the output is 0. This one. And both A and B are high, the output is high. This one. And also for either of the input is high, the output is high. Okay, this is the timing diagram, output timing diagram. So that means the output is low only when both the inputs are low. So the OR gate can be constructed using two diodes. Using this circuit, here if both the inputs are low, that means A and B are low, the output is low. If either of the input is high, the diode conducts and the output is high. If both the inputs are high, there is also an output. That means the diode conducts when either of the input is high or both the inputs are high, and it does not conduct if both are connected to ground. Thus this acts as a OR gate. Now the NOT gate. The output of the NOT gate is high if its input is low, and the output is low when the input is high. Symbolic representation A bar, A NOT. So the NOT gate is also called an inverter as it inverts the input. So this is the truth table. When A is 0, the output is 1. When A is 1, output is 0. And this is a timing diagram. For 0, a high output. For a high input, there is a low output. A NOT gate can be constructed using a transistor. Using this circuit, VCC is given as plus 5 volt. An input of 0 or plus 5 volt is connected to the point A. The input is connected to the base through the resistor R2. When no voltage is present on the input, the transistor is off. When the transistor is off, no current flows through the collector emitter junction of the transistor. The current from the supply, that means VCC, flows through the resistor R1 and reaches to Y. When the voltage is present at A, that means when A is connected to plus 5 volt, the transistor turned on, thus the plus VCC and the current through R1 passes through this transistor and reaches the ground, so the output is 0. Thus, the transistor acts as a NOT gate.